Hello everyone, thanks for joining me. This is going to be the second part of our tutorials on resistance. Now the first part was on theory, and then this part is going to be just on resistors and some of their functionality and the different types of them. So let's get started. Hello everyone, thanks for joining me. Well, this tutorial is going to be on resistors, and we get started here with what are resistors. Well, resistors are devices that conduct electricity, but they also dissipate electric energy in the form of heat. What they're used for mainly is, well, so we don't blow stuff up, but resistors are used to reduce the supply voltage or to limit the current, and there's a lot of different ways to do that. And we'll get into that when we get more into the circuit design. Resistors are made from low conductance materials, and generally resistors with high resistance rating will have a low wattage rating. And the power and wattage ratings determine its size and shape, and you'll see that they come in all different sizes and shapes. Now there are two basic types of resistors. There's fixed, and then there's variable. Now the fixed are the typical ones. You've probably all seen them in electronics. Those are the carbon ones that are color banded to give you the values on them. And then there's the variable ones like potentiometers and rheostats. Now fixed resistors, this is a schematic that you'll see on a diagram where you're going to build something. You'll see that is the schematic symbol for a fixed resistor. Carbon composition resistors are the most common type of resistors that are used in electronics. And you can see the design there. They're very simple, a carbon mixture and insulating material with the connecting leads. Now, fixed resistors, there are four basic categories of fixed type resistors. There's a carbon composition, then you have your film, your wire wound, and your chip. Now, this is the carbon composition again. And the reason that they're used very widely is they're relatively inexpensive. And they're available in power ratings of 1/10 of a watt to 5 watts. Now, carbon composition resistors are used widely in low power applications and typically under a watt. They have typical tolerance of 5 or 10%. Now, carbon film resistors are different. They have less noise, and that's why they're used, and they're used a lot in the audio and communications industry. They have a more exacting tolerance on them from 2 to 5%. Now, wire-wound resistors are totally different than any of the rest of them. They're made of alloys of high resistivity, and they have greater stability, and they supply up to 250 watts. Now, you'll see down here, you'll see that the values are usually put right on the outer coating there instead of the color coding. Now, chip resistors have become really popular. They are small, high-quality resistors manufactured on small rectangular chips, and you can see the alumina substrate and the wrapped around electrode and the protective film there and the resistive film in the electrode. So you can see how the construction of them. These lay on circuit boards, and instead of the through mount technology where the pins come down, they just solder right on top of it. So they have become very popular. Like I say, they're used a lot in surface mount, or SMT as they're called, for the circuit boards. Now, variable resistors, there are three basic types of variable resistors. There's manual, there's heat, and there's optical. And you can see there are some manual variable resistors, rheostats. You'll see those used a lot in lighting or just a ceiling fan. And then there's the potentiometers. Now, any potentiometer can actually become a rheostat. If you see on here, instead of having the 2 wires up here, you'll see there's 3 leads on there. Now, if you just don't use that one lead on the potentiometer, you can use it as a rheostat. Now, rheostats and potentiometers are used to control a circuit current by varying the amount of resistance in there. And many uses, volume control, that's really common, dimming the lights, etc. And here's a schematic symbol for variable resistors. Now, these are just some of them. There are some other alternative or alternate schematic symbols for variable resistors as well, but these are probably more common ones. Now, thermistors. A thermistor is a resistor whose resistance varies with temperature. And they are most generally made of semiconductor materials and very sensitive to changes in temperature. And this is a schematic symbol for those. Now there's another kind that I didn't put on here, but they're used, you've probably seen like in surge protectors. They're called a varistor. And that's just a combination of the word variable and resistor. And what those will do is if they'll choke off the current coming through if you get like an overload. Now here's photoresistors. That's another type, and you can see those. They're used in like for yard lighting and stuff where you only want it to come on as it gets dark. Now photoresistors are also made of semiconductor materials, and the resistivity changes with the level of light. And the symbol for photoresistor, if you see it on a schematic, that is what that one will be. Now resistor color code. I say the most common type of resistors that you're going to be working with are these carbon ones. They're inexpensive and they're used a lot, especially by hobbyists. And you'll find that this is what you're going to be doing, whether you're building something on a breadboard or whatever you're going to do, building a radio. This is what you're going to find. And you can see on here that with these color codes, each one means something here. Now this red band on the bottom here, you can see that that lines up with a 2 on that first band. So the first band will give it a value of 2. The second one is orange, and you can see on the second band that is a value of 3. And then this third one is violet, that's 7. And then this one right here, now that tells you the multiplier. And you see this column of multiplier, so we're only going to multiply that by 1. Now these 5-band ones are more accurate than the 4-band ones. So we'll take this one and we multiply it by 1, and then we take which will give us a 237 ohms, and then we're going to come down to here and we're going to look in that brown, and that gives us a tolerance of plus or minus 1%. So that's a pretty accurate resistance, and sometimes you just need it to be that accurate. Now on this other one here, you can see where that comes in at. And it's the same thing. You're just using the green, the blue, and the yellow, and then that brown. So that's pretty much what I have on resistors. I appreciate you joining me, and we'll see you again next time. Well, that's all we have for today, and then our next tutorial is going to be on Ohm's Law, and we'll see you then.